Hello and welcome to the logic of it all. This is our first video about graphs, and in this video we cover some of the basic definitions. Graphs are used in many different areas in computer science. Here I listed some of those, for example, in computer networks, in data structures, programming languages, operating systems, and AI. We use graphs to model different concepts and ideas. Historically, we can say that graphs are first used to answer this problem, where in this city there were 7 bridges, and people always in that city asked the question whether it's possible to traverse all the bridges exactly once, which means you go through all the bridges, you don't miss any of them, and also you don't traverse the same bridge twice. So the question was whether such a tour or whether such a walk is possible. A famous mathematician named Euler used a mathematical abstraction, as you can see here, which we call a graph, to simplify that problem and bring out its essence, which is the connectivities. And using this abstraction, using this graph, he was able to answer the question negatively, which means such a walk is not possible. And we can say that this was the beginning of studying graphs and graph theory. Now, starting with the actual definitions, we start with the definition of an undirected graph. So in an undirected graph, we have a set V, where V contains what we call the nodes of the graph or the vertices of the graph. And we have another set E, which contains the edges of the graph, where each edge connects 2 vertices. And if we have an edge connecting 2 vertices U and V, we denote that edge by the set U comma V. The reason that we use a set is, in a set, the order of the elements is not important, which means the set U comma V is the same as the set V comma U, which means if we have an edge, the direction of the edge is irrelevant, and that's why we call this an undirected graph. So the edge connects U and V, but it doesn't have a direction necessarily from U to V or from V to U. And here's our first example. So you see in this graph, we have 4 nodes or 4 vertices, namely M, H. So these are the vertices, M, H, L, and S. So these are the nodes. And the lines connecting some of these vertices are the edges. So we have one edge connecting M and H, another connecting H and L, and so on. And you see that there is no direction from M to H or vice versa on these edges. And that's why we call this an undirected graph. So if you want to write this mathematically, we say V, the set of vertices, contains H, L, M, and S. And E, the set of edges, contains the edge connecting M and H, the other edge connecting H and L, and then 2 more edges. So 4 vertices and 4 edges. For directed graphs, on the other hand, our edges are directed, which means the edge is specified that it goes from, let's say, U to V or from V to U. So each edge has a specified direction. Now, the way that we do this mathematically is to represent an edge. Instead of using a set where the order does not matter, we use ordered pairs. So an edge going from U to V is denoted by the ordered pair UV. And in that case, so if we have UV as an ordered pair representing an edge, it means that that edge goes from U to V. So we call U the start vertex and V the end vertex of the edge. And the default usually is that if we don't specify whether the graph is directed or not, we assume that it's not directed. So the assumption is the graph is undirected unless it's specified otherwise. Now, here's an example of a directed graph. As you can see, we have 4 vertices again, H, S, M, and L. So this is our set of vertices. And the edges that we have an edge going from H to S. So that's the ordered pair HS. We have another edge going from L to S. So that's the ordered pair L comma S. We have an edge going from M to L. So that's the ordered pair M and L. And then we have two edges, one going from M to S, which is this ordered pair, and then the other one going back from S to M, which is this ordered pair. So the graph has 5 edges and 4 vertices. Now, note that in this graph, for example, we don't have an edge going from L to M or from S to H, for example, right? Because each edge has a specified direction. Now, in here and in many introductory textbooks on graph theory, the study will be restricted on what we call simple graphs. Now, to define what a simple graph is, we need to define two concepts. The first one is the concept of a loop. A loop is an edge where it starts from the vertex A and ends at the same vertex. So an edge that connects a vertex to itself. And the second concept is the concept of parallel edges. So if we have two edges where they connect exactly the same vertices, so one edge from between A and B and the other one also from A to B, then we call these parallel edges. And we call a graph simple if it doesn't have a loop and it doesn't have any parallel edges either. Now, to make it more clear, we look at an example here. So here's an example. The question is whether this graph is simple or not. And if you look, you see that between A and B, there are two parallel edges. One is the arc, and then the other one is the straight line. And because of that, this graph is not simple because it has parallel edges. Here's another example. This graph has 3 vertices and 3 edges. The question is again the same, whether this graph is simple. And again, the answer is no. And this time because we have a loop. We have an edge going from one vertex to itself. So neither of these two graphs is simple. The next definition is the definition of the degree of a vertex. So when you're studying a network, this is one of the metrics that is going to be very important. You want to know how important that vertex is. One of the ways that you can measure that is to see how many edges are connected to that vertex. And that's called the degree of the vertex. And if the graph is directed, then we can talk about two types of edges. The edges that go into that vertex and the edges that start from that vertex going to another one. And if you count the number of edges going into V, we call that the in degree. And the number of edges that's coming out of V is called the out degree of that vertex. And in directed graphs, we define the degree of the vertex to be the sum of its in degree and its out degree. Now again, to make all these definitions clear, here's an example. So the question is, what is the degree of A, C, and G in this graph? So first of all, this is an undirected graph, and it has 7 vertices. Now for A, we see that there are 2 edges connected to A, namely this edge and this edge. So degree of A is 2. For C, down here, there is an edge coming from above, this edge and this edge. So 3 edges connected to C, which means that the degree of C is 3. And if you look at this node here, G, you see that this vertex doesn't have any edges connected to it, which means that its degree is equal to 0. Now, in an undirected graph, we need to be more careful because we need to talk about in degree and out degree. So here the question is, in this directed graph, what's the in degree and out degree of these 3 vertices, A, D, and E? For A, if you want to look at its in degree, there's only one edge going into A, so its in degree is 1, and there are 2 edges going out of A, so its out degree is 2. For D, down here, you see that there are 3 edges going into D, 1, 2, 3, and there is 1 edge coming out of it, so its in degree is 3 and its out degree is 1. And finally for E, here you see that there is 1 edge going into E, so its in degree is 1, and there isn't any edge coming out of E, so its out degree is 0.